Welcome to the project demonstration of fault detection while home automation system. So here we are using the device controlling through the two modes. One is a Bluetooth voice application based, and next through IoT. So from the Blynk application we can control the devices, and the next controlling from the Bluetooth and Wi-Fi, and the next is automation with help of sensors. So whenever the darkness detected, and that will be identified with help of this LDR sensor, then only the light will switch it on. Then before that the user has to provide the instruction to on the lights. Means when the user on the lights, then based on this LDR sensor, means light intensity, then only the light will be getting on and off continuously. And when we off that, irrespective of the LDR input, the system won't control this LED. And once we on the LED, then the status of the LED, whether it is on or is any fault detected, that will be getting from this LDR sensor, and based on that the system will show the status on the LCD screen, and the same status uploaded to the thing like our Blynk application to get to know the light fault, whether it is a light fault status or is on status. The same for the fan also. When we control the fan, is directly manually controlled, and sensors data like humidity, temperature from this DHT11 we can get to streaming into the Blynk application directly. So to achieve these features, mainly we are using the power supply of 230 volts AC inputs to the transformer, so which will step down the 230 volts AC to 12 volts of AC, and that will be converted into the 12 volts DC with help of this regulated power supply board, and the 12 volts DC is input to the LEDs and a fan parallelly through these transistor boards. So these are the main switching devices. This is a switching device to control the fan, and this is a switching device BC547 transistor to control this LEDs. And our operating voltage to our Arduino Uno, which is main processing unit, is a 5 volt, and for that purpose we are making use of LM2596 voltage regulator, so which will provide us a 5 volts DC output. So the DC is input to the breadboard. From there the voltage will be distributed throughout the input output modules. So like Arduino Uno processing unit, and this one is the LDR sensor module is the input, ESP8266 Wi-Fi module which is used to communicate between the Blynk application to the Arduino Uno board, and the HC05 Bluetooth module to communicate from the voice application, and this is the current sensor which will get to know the status of the fan. And these two are the transistor switching circuits for fan and the LED, and this one is the LDR board, and here is a DHT11 to get the humidity and temperature, and the so-called status continuously displayed on the 16:2 LCD screen. And before demonstration, so first of all we need to enable the hotspots. So for that, configure the hotspot name to configure the hotspot name to project 7378 without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 gigahertz. After enabling the hotspot and data, enable the hotspot and data. Now one more application we need to install, that is Arduino Bluetooth control application. So from there we are going to send the voice commands to control the device. So after installation of this application, so we need to configure the buttons, means voice commands. For that, go to settings, and in that voice commands, so command 1 to the fan on and the data to be 1. Same for fan off and data is 2. Same for light on and data to be sent is 3. Same for fan off, so light off, and data to be 4. So these 4 commands to be set from the settings, and then after install the Blynk application, Blynk IoT application from the Play Store. So install this and log into this one given credentials. There we get the LCD, same data will be sent here also, and manual controlling from the Blynk application, on off the light and fan, and status about the fault identification will be get to know this from LED indications on this Blynk application. So after all these settings successfully done, now go to Bluetooth. So initially when we are demonstrating in a mobile phone, so initially we need to pair from the Bluetooth settings so that it will be there in our paired devices. So I'm showing from initial setup onwards. Now on the power supply, welcome message will be displayed, and you can see one device will be connected in your mobile phone. So you can see that one device is connected. Okay, so after that, now pair new device. So wait till SC05 coming, so it will ask for the password. So the password is 1234 we need to enter. Now it will be there in our paired device. Directly go to the application parts. Okay, so in this, our voice control, light on, So when the dark detected, sorry, it's connection. So on LCD we can see the night mode and dark mode. Right, so after opening the application we need to pair to the SC05. Right, after pairing from here, so connected device, now open this. Light on. Right, the light got switched on. So whenever the lighting more here, so we can see the light will get switched off. This automation process was enabled from this voice application. Light off, fan on, so the fan is running now. Fan off, fan off,
fan off.
Actually for that we can configure these voice commands to our user convenience, so we can change it to single off. And now fan off. Right, so it will be recognized and fan will be the off. So this is the voice communication along with automation. And next go to the IoT feature. Now go to the Blynk application. So here we are getting the same data which is displaying on this screen. Same we can see this. Okay, and now just on the fan. So the fan is running now from the Blynk application. So the fan is running status. And when we disconnect this, this continuously is getting on as there is no current driving to the fan. Now fan off. Okay, and same light on. So the light got switched on. So in the day mode it will be off, so everything is normal. But in the night mode, so whenever the fault detected, means I'm disconnecting the LED instead of making a fault, so I'm making the fault manually, so that we can see the light fault indication on the Blynk application. So it's normal again. Right, so in this manner from voice communication we can control the home automation along with IoT and monitoring of sensors data continuously on the LCD here locally, and from IoT application from anywhere in the world we can access the data. So you can see the humidity, temperature values and the light status monitoring right directly. Right, thank you.